I'm going to go ahead and turn it over to each of our faculty to introduce themselves. And as I indicated before, while I'm doing that, I welcome you to start filling the Q&A with your questions so I can turn those questions over to our faculty once you get to know them a little bit better. Qiaozhu, can we go ahead and start with you?
Absolutely. Thanks, Amy. Hi, I'm Qiaozhu Mei. I'm the faculty director of the maths program. I lead a group of faculty members and staff of UMSI to oversee the curriculum and execution of the degree program. So when I take my director hands off, I teach in the maths program as well. I actually teach four courses, data mining 1, data mining 2, search and recommender systems, and also the capstone projects. And beyond teaching, I do research in large-scale data mining, machine learning, lots of interesting stuff of how to actually use data science techniques to improve everybody's daily life. We recently have a paper about using emojis to help retention in remote work. If you're interested, I'd be happy to take more. Thank you.
Thank you, Qiaozhu. I would definitely be interested in learning more about the emoji research, being a person that uses many emojis every day. So we will definitely have to come back to that. All right, I'm going to go ahead now and turn it over to Elle O'Brien.
Hi, everyone. Welcome. It's nice to be here with you today. So I am a lecturer, which means I'm part of the teaching faculty, and I lead the capstone class much of the year, although sometimes Qiaozhu does that also. And the capstone is a class where you get to make a project that is kind of like a portfolio piece that really synthesizes what you've learned and applies it to some new and exciting piece of data science that you would share with the professional community. And I also conduct some research about how organizations carry out data science and machine learning.
Great. Thank you so much, Elle. And then finally, last but certainly not least, Kevyn Collins-Thompson.
Thanks, Amy. Hi, everyone. I'm Kevyn Collins-Thompson. I'm an associate professor of information and computer science. And I guess I've been with the maths program from the beginning. I worked closely with Qiaozhu and many other faculty members to design it. And I love teaching in the maths program. I teach 2 of the core machine learning courses, supervised and unsupervised learning. And I've also been leading the milestone 2 project courses, which are a critical sort of waypoint. There's 2 parts to it. We can get into the structure of it later, but it's a project-oriented section of the curriculum that's proved really interesting and valuable for me and for the students. I guess when I'm not teaching maths courses, my research is basically into how machine learning can help human learning. So I combine natural language processing, applied machine learning, even techniques from finance and economics as well. So I love to do interdisciplinary research. And my background, actually I spent quite a while in industry before I worked at Microsoft Research for a number of years, and also was one of the original developers of Windows 3.0, if you can believe that. So, but I've been in Michigan for 8 years, and so I've seen sort of both sides, both of research and development. So, and I'm very happy to be here.
Great. Thank you so much, Kevyn. I did not know that about you. So now I feel like I've learned a little bit of something here.
I feel old.
I do too. So and that's okay. And one of the benefits actually of the maths degree is our student population is incredibly diverse. So we have folks that are as young as coming right out of their undergraduate college degrees to as old, and I mean that in a very positive way, as folks that are well advanced in their careers and in their 50s and 60s. So by virtue of age, amongst many things, we've got lots and lots of different folks in our maths community. So we are already getting some great questions, and I'm going to start with one that I would actually like to hear from all 3 of you, because I'm guessing that each of you have a related yet distinct way in which you would approach this question. So Elle, I'm going to start with you, and then we'll go from there and also get Qiaozhu and Kevyn's feedback. The question is, how do you differentiate your master's degree compared to other online data science degrees?
Yeah, so first of all, there's a really big applied focus. And that means that a lot of people come in with, some existing strengths in an area, like maybe they have, a really solid psychology background, or, they've been working in a domain for a lot of years, and they want to add enough data science skills that they can, just really get down to business and start working, with data in their domain of interest. Some people are doing a complete career switch, and maybe they completely leave their original domain, but, we have some really, really talented students. And so by the time people get to me at the capstone, they've taken a variety of classes, usually things like natural language processing, the basics, and, really, really strong, data visualization skills, data storytelling. And so they'll create a project that usually marries together a couple of disciplines of interest. And so, some people who are really into, sports analytics will come out and they'll make, machine learning models for predicting. We had a really great one about like player injuries recently. That was so cool. Other people will make a project that delves into their interest in finance, and financial modeling, and then they can use that as a launch pad to, get ahead within their own, organization of where they're primarily working. So I see MADS as being super applied, pretty fast, right? You get, right into things. And it mixes and matches really nicely with, a lot of the things that make you, so you can, you don't have to, you can often just I just see a lot of people who want to take what they're doing now and be able to do it with data. And they, can really launch themselves into cool places in their careers.
Great, thank you, Elle. You made so many fantastic points about what distinguishes MADS. What would you add to that, Qiaozhu?
Well, thanks, Gail. This is really well said. One thing that we're proud of about MADS is our curriculum, which is unique. It finds a very nice balance between rigor and flexibility. So our curriculum is well designed by the top class, the world-class faculty members at U of M. It is unique in the market. It's what we call end-to-end data science. It has the full spectrum of how to formulate the real-world problem into a data science problem, knowing your stakeholders, right? How to collect data, how to process, manipulate the data, how to deal with big data, and then how to apply the state-of-art machine learning data mining techniques. As you can see that we have 5 machine learning courses in the program, right? 2 data mining courses and more, lots of advanced analytics technology courses. And then we have courses that helps you to visualize the data, to present your data science results to the stakeholders, to not only presenting the results to them, to help people make real decisions. So we have courses like experiment design and analysis. We have courses like causal inference that tries to help you draw causal conclusions from the experiments and from the data. And we have, the courses connecting the other end, how to apply what you have learned to actually solve real-world problems in real-world domains. We call them application courses. And we have 3 project courses that help you to really, synergize what you have learned to solve, fancy data science problems in reality that you are so proud to put on your resume, to put into your portfolio. So this is very unique. To make sure that students can actually, accomplish this ambitious and rigorous curriculum, we embedded lots of flexibility into the design, right? So you can see that our courses are month-long, right? And they're highly modularized. That's helping students who have other important duties in your life. You have work, you have family, you can still find time to actually learn at your own pace. You can take 1 course per month, you can take 2 courses, you can take 3 courses per month. When you have other big events in your life, in your work, you can actually slow down or you can speed up sometime, right? So this is it's like you're solving this, problem of assembling the building on your own using all these building blocks that we provide. So that makes us very proud of the curriculum. In fact, there's the interesting fact that I list 3 particular courses: data science ethics, that really helps us to understand the real world impact of the data science project to the society, right? Before you even started to deal with data, right? Understand how the project, how the approaches, right, is meaningful to the society, to real people. Causal inference, as we said, is drawing causal conclusions, helping people to make decisions, right? And also reinforcement learning. That is the advanced branch of machine learning, right? The reason I mention reinforcement learning is that, not because that, supervised learning and unsupervised learning or deep learning are not fancy enough. It's like you have to get all these backgrounds to get into reinforcement learning. Right. Actually, I don't know any other data science program that actually has the combination of the 3 courses. If you know one, you can tell me.
Great. Thank you so much, Qiaozhu. That was a really lovely overview of a number of different facets of our program that distinguishes it in a market of data science degree programs. And I think particularly your points about flexibility and about the benefits of the applied approach really resonate with me. Kevin, what else would you add?
Well, I would only add that I think the Master's of Applied Data Science degree reflects the special values of the School of Information, which are to create and share knowledge so people will use information with technology to build a better world. And that's reflected, as Qiaozhu said, in a broader view of data science. So data science is not just a bunch of algorithms, it's not just a bunch of statistical theorems. It's really thinking more broadly about how this technology interacts with and affects people. And that's the way that technology is trending now in our society. So companies that are hiring in AI aren't just hiring machine learning specialists and PhDs. They're hiring a much broader set of people now because of the impact that this technology is having. And so I feel that in both in the incredible diversity of the students, the incredible research and diversity of interest in, the faculty have, the design of the curriculum, I feel it reflects the special values that the School of Information has, that looks beyond has a broader view of data science.
Thank you, Kevin. And I appreciate you contextualizing the degree in the larger school setting, because we work very diligently to ensure that the MADS degree is well represented in the school community and that the MADS degree benefits from the larger school and all of the things that the School of Information has going on for it, and that we are situated within the context of the University of Michigan, which also has many benefits as in so much as its position as a large research institution that also cares deeply about the teaching and learning of students. So, Elle, one of the things that we often talk about, and we have heard also from data science leaders in the field. So, for example, when we had the lovely Andrew Ng join us to talk about the differences between data analytics and data science, one of the questions that we got is that question. So, can you tell us a little bit about how we think about and act on what data science is and how we distinguish that from data analytics?
Yeah, so, I'm sure there are a variety of opinions about this, and how these words get used. And in some places they're used synonymously. But for me, when I think of analytics, I tend to think of a family of, statistical tools, whereas I think of data science as a kind of craftsmanship. So when data science, a lot of people are very surprised to learn that they actually won't be spending most of their time, or, depending on the application, on doing trying out a bunch of different modeling approaches or approaches to predicting or fitting your data. You actually have to spend quite a lot of time engineering. How do I get the data here? How do I work on a computer that can handle my data? Because not all data fits, nicely on our, desktops. And then how do I get my data into a form that I can begin to look for patterns in it? And that actually turns out to be a surprising amount of work. And then when you're done with that, finding out how to turn that into value, right? Because in data science, value is not just what you found in the data. It has to be transformed. And that's actually a process that takes a tremendous amount of human skill. And so I really see like all of those parts of it are data science. So it comprises some data engineering, a little bit of computer science, and then, how do you communicate that and turn it into a lasting product of value? So to me, data science is this huge thing that, there's lots of ways you can specialize. But I think of us as like, I don't know, like maybe the same way of like plumbers or carpenters. Like there's a big set of craft and skill that goes on there. And it's actually bigger than a lot of people expect.
Thank you, Elle. I really appreciate that conceptualization. And what you touched on that I think is really important, and is that we are preparing people for the complexity of those jobs, right? That in fact, we are responding to what the market demands are that are requiring a spectrum of data science, well-trained data science folks, some that will work on the data analytics end, and some that of course will work on the data science end. And that in fact is what our program is designed to do, is to prepare those data scientists to be strong collaborators and also really positive leaders in the data science career field. Speaking of career fields and paths, Kevyn, can you tell us a little bit about where some of our graduates have gone, or where you would anticipate that people would go with a degree like the maths degree?
Sure. I mean, I think one definite trend is that, as I said in my earlier remarks, the scope, data science and AI, machine learning are no longer the province of just a bunch of specialists. You really need people who can be the bridge, for example, between the specialists and the business people who understand the technical aspects of a problem or an analysis and can communicate that effectively to non-specialists. That's an incredibly important job, and that's an example of a career that I'm seeing more and more in almost every aspect of machine learning, for example. So that's just one example, I think, of the kinds of things that students are doing and will be doing.
I think it's a fantastic example. And one of the things that I love about our curriculum is that we include courses that enable folks to build skill in that area. So we talk about things and act on things like presenting data science, or visualization, our visualization courses, and how those visualizations might be narrowly tailored to a group of other data scientists versus a lay audience of folks that need really powerful but also understandable visualizations in order to help them make data informed decisions. Qiaozhu, you also know a lot about where our graduates, and admittedly, we don't have that many yet because we just launched in the fall of 2019, but people are starting to graduate from our degree program. What kinds of things are you seeing about where they're going?
We actually have more than 100 graduates now, and by the end of the winter semester, we will have more than 200 students who have completed their capstone requirements. That doesn't mean that they want to graduate. They may stick in the program and take all these new electives. Many of them told me that, but we have a good number of graduates. Our student body is really diverse. They have very, very different desires to do data science, to use the techniques they learned. I see multiple trends among our students. We have students who previously understand more about people, more understand about how business is done in their field. And they wanted to learn data science. They wanted to learn the techniques to better understand how the decisions were made and to help them make better decisions for the people. And these students would normally stay in their domain, but take different roles. Like they could be, for instance, a lawyer. Right? They could be, for instance, a software engineer. They could be a project manager, and they wanted to take data science related roles like data scientist, or even they don't change their job title, then we just change the way that they do things. Right? We also have a large body of students who wanted to switch career. Right. So we have very good examples of them. For instance, we have a star student who came into the program as the dental hygienist, and now she's the data scientist working for Blue Cross and Blue Shield. Right. We have students who wanted to use all these techniques to do something much more ambitious. So we have students who finished the program and started a company, right, working in data science. We have students joined startup companies as chief data scientist, right? We have students who are on the path of making things done and build something that just didn't exist ever before. So we have a wide range of students. I think this is why that we really love this program, right? If you see the diversity of our students' background, and you see how different their capstone projects are, how ambitious they are to actually change the world within the they think. I usually tell the students that it's not like the world has the positions and then they wanted you to fill in these positions. It's you are actually changing the world, right? You're helping the world define what is data science, define what is the next generation of domain experts who understand data, or data scientists who understand the domain, or data science who can actually connect multiple domains, data science who can actually make it happen so that AI is not just AI. AI is the joint work with AI and people, right? So it is artificial intelligence plus human intelligence. So our students are actually shaping the scope, the net scope of data science.
Great, thank you. It's quite inspiring, in fact. So we've been talking a lot about our students and graduates. And so if we can back up a little bit, before you become either of those, of course, you start as an applicant. And so Qiaozhu, what would you recommend applicants do in order to prepare themselves well for our degree?
That's a really good question. So the practical answer is that we have, the entrance requirements. We have tests to see whether you, have the background in Python programming and in statistics, right? So get a good preparation. If you have taken stats courses a few years back, then refresh your memory about the concepts. Right. Of course, if you're, for instance, if you're a programmer, if you use Python in your everyday work, we will waive that requirement, right? But in general, refresh your memory about how to program, right? If you have time, take a look at our Python specializations, offered on Coursera. That will also help. Right. And I think the most important thing is to get prepared mentally, right? Know that we're trying to, make it happen. We're trying to solve this big problem, right? Know that, okay, there are different ways that I can really benefit from taking these courses, from getting a degree, right? And also be prepared to embrace the flexibility. You can see that in our curriculum, we offer lots of flexibility to the students. Right. But it's a different story whether you can actually leverage the flexibility. Right. So get mentally prepared. Right. There's definitely no need to move very fast or very slow. Right. Just find your comfort zone. Right. Know where your comfort zone is. Know how to actually find the learning pace that works the best for you. And then just embrace data science.
Excellent. Thank you so much. Kevyn, relatedly, how would you encourage people, or to what level of proficiency would you encourage people to have in Python when entering the maths degree. So given, for example, the courses that you teach in machine learning and the sophisticated use of Python, but yet at the same time, the supported approach that we take to helping people grow those skills, can you tell us a little bit more about what makes people kind of ready for success in that way?
Sure. I think having a basic understanding of sort of basic programming ideas, like being able to know what functions are, what variables are, basic constructs like being able to loop through a series of values and so forth. The thing about a lot of the work actually in machine learning, it doesn't involve writing thousands of lines of code. A lot of the programs that you'll be writing as part of the homework assignments, for example, are fairly short. So it's not like you have to master incredibly complicated data structures, incredibly complicated programming design. We don't like complex aspects of object-oriented programming. You don't need any of that. You just need a basic understanding of Python. I think we have, the School of Information has a Python 3 MOOC, which would there are other ones, good ones, I'm sure, but I'm most familiar with that one. That would give the basics of, what are variables, what are different types that can go into a variable, strings, floating point numbers, things like that. Once you start getting into the more programming aspects of our data science classes, you become familiar with, so we use heavily packages like NumPy, which is a scientific numerical programming library that makes very easy to do things like multiplying two matrices together and things like that. So we rely heavily on Python libraries. So a lot of the functionality that you're using is inside the library. The Python itself is fairly, as I said, it doesn't involve writing huge amounts of code. So it's, I think that there's a certain mindset once you're used to programming, of being able to take a problem and break it down into smaller problems that you can then solve. That's really good to have practice at. And then, yeah, so I think that's sort of a summary on the programming side.
Great, thank you. I think that really surmises well the way in which we think about and hope our applicants and then eventually students act on what it means to build Python skills. Now, we picked Python because, in fact, the majority of, if not all of our faculty in the maths program, almost all, know Python really well. That's our kind of computer language of choice in the school, not just in the maths degree, but throughout UMSI. And so, of course, we get the question, why Python? Elle, you are a person, of course, that knows multiple programming languages because you program in Python and in R, for example. Can you tell us a little bit about the advantages to using Python for data science?
Yeah, so I am a tremendous R fan, and it is probably one of my favorite languages ever, but it does seem like a lot of the open source tools in data science that get a lot of traction seem to be starting in Python. And so leading with Python is a way that we help everybody have access to, some really cool developments. Like, there's just more support for certain deep learning libraries for things like natural language processing with some really large models. So it tends to be right now, for some reason, that the bleeding edge is often closer to Python, which is why it makes a lot of sense for students that are going to need to be, trying, a lot of applications. You don't want to be limited by finding out that your amazing idea can't be carried out with a library that isn't available for your language. If you have experience in R, that's wonderful coming in, because a lot of that knowledge will transfer. I learned R before I learned Python, and it made learning Python a lot easier. And there's certainly no, wrong language, but it does seem like, for whatever reason, in data science and machine learning, kind of the primary language in a lot of, free and very cool software projects right now seems to be Python.
Great, thank you, Elle. I think that speaks to both how we employ Python in maths, as well as why the school made a dedicated choice to use Python as its primary programming language. That said, Qiaozhu, you know, and I know that we have a lot of folks in maths who this is their first technical degree experience. And so they come to us and then they talk about Python all the time. And of course, all of us know there's lots of great Python memes that go around our Slack workspace because our students learn the joys and the pitfalls of programming in Python. So can you talk a little bit about when we say we're a technical degree for non-technical folks, what does that mean? And how do we really support people so they're comfortable leaning into a technical degree, even if they come from a non-technical background?
Mm-hmm. Thanks. I saw the question in the Q&A session that you know, what if I have a non-technical degree in finance? That's very intriguing, right? Why you call finance the non-technical degree, right? So, you know, as I said that, the goal of building this program is not to, you know, train a bunch of, you know, talented programmers to be able to deal with data, right? Is not to, you know, train the computer scientist, right? Like, you know, Kevyn used to be, right, working on Windows 3.0, and we ask, hey, Kevyn, right, come here and take this degree. Now you can actually, you know, work with data science. You know, we have way more students who understand better about people, about the domain, right? And we hope that by learning the data science techniques, by learning the, you know, the technical side of these, they can actually bring the techniques back to change the world, to actually make the people that understand live a better life. So that's our mission. That's actually Michigan's mission, right? So we create, you know, lots of, you know, channels for the students to get into these technical details step by step, bit by bit, right? So it's not like when you come into the program, the first task you're dealing with will be dealing with terabytes of data, and you're trying to, you know, build a deep learning model that works on that. No, you start with, you know, how to just get familiar with data. What do we mean by using Python to load the data from the files and then to do some, you know, my preparations to transform data from one format to another, right? That is just one step beyond, you know, the Python proficiency that Kevyn has been talking about, writing functions, right? Writing loops, right? And then once you're familiar with that, we take one step further, right? We'll tell you, okay, now you can write a program to deal with small scale data. How about let's deal with a little bit larger data, right? How about if we can use some more, you know, smart data structures, right, in Python, or use some existing packages in Python to help you achieve that goal, right? So previously you have to do this in, let's say, 5 minutes. Now you can write efficient programs that can do this in 5 seconds, right? And then we gradually add into the curriculum, like now you have a mathematical equation, now you have some statistical method. How can you write code to actually make it work, right? And then we're going into machine learning courses, right? As Kevyn said, that we don't ask you to write, you know, 10,000s of code to reproduce the machine learning algorithm from the scratch. Instead, it's more like how to make use of, you know, the packages people have already written, how to understand what's behind them, right? And then how to make use of these building blocks. In fact, when we chat with Dr. Andrew Yin, there's the metaphor that, you know, the next generation of data science could be architects, right? Rather than, you know, rather than programmers per se, right? So the daily life is to know what works in what scenario and what combination of building blocks would help you solve the problems instead of building everything from scratch, right? Writing 10,000 lines of code. I don't know, maybe Kevyn, you wrote 10,000 lines of code when you developed Windows 3.0, but the world has changed.
Yeah, we don't write in assembly language anymore.
Well, thank you for that. That is, it really resonates with me because it demonstrates time and time again how we get feedback from our community that folks who came in who were nervous, understandably, because they were new to this world, and yet became a deep and strong member of the data science community, and then ended up taking those skills and that knowledge and all of the benefits of being a University of Michigan alum, and went on to practice data science in the field of their choice. So we've been focusing a lot on programming language, understandably, because that is really essential to the degree. But in addition, we have some other technical requirements as well. So for example, we have a math requirement, and we have a statistics requirement. Elle, can you talk a little bit more about how we think about and act on proficiency in statistics and why that's so critical to the study of data science?
Yeah, so we are an applied program, which means we're not usually going super deep into the theory. And I would say that, I think that a lot of the future of statistics education is extremely applied, because it's actually in some ways easier to learn when you just get started manipulating data. But one of the biggest issues in machine learning and data science is that we are looking for patterns, but it turns out that randomness can create a ton of things that look like patterns, and it's easy to fool ourselves. So, we use statistics. There's a couple of big ideas in statistics that, people have to grasp, and it's really about how to be, appropriately skeptical of your own findings so that you really dig into them and make sure that you believe they're meaningful, so that that what you've created is not just an artifact of the data that you randomly happen to get, and reflects something that really exists in the world and is of value to people. So statistics is not, you're not going to come out of this with like a super theoretical background, unless you're into that, in which case, a lot of us are very happy to talk to you about that, myself included. But what we're really looking for is like a comfortable working knowledge of a couple of fundamentals that are kind of like guardrails, that keep your data science rigorous.
Excellent, thank you. Yes, we really pride ourselves, right, on this great combination of increasing Python skill, developing statistical literacy, strengthening math skill, but doing it in applied ways so folks can comfortably navigate the complexity of those topics and be well skilled, but not in a way necessarily that feels overwhelming. So speaking of flexibility, Qiaozhu, we do have a couple of folks that are really interested in knowing about how this actually works. So how do these 1-month courses work? Do you go at your own pace? Not, what does it look like in practice? Can you tell us a little bit about how we set up the degree using this 1-month, 1-credit course and model?
Absolutely. So it's more like exploring in a space, right, where you actually have multiple stops, right? You can choose, okay, and I'm going to visit this place, and then wait for a while to visit another, and you actually have multiple options to move from one station to another. So every course is offered 3 times a year. So they will appear 3 months, 4 months later if you don't choose to do that this time. And every course has a few prerequisites. You have to take these courses to get into this one, right? And once you have taken this course, that opens the door to next few courses, right? So that's it. You can choose to take 1 course per month, right? Or 2 courses per month, or 3 courses per month. So you can finish the degree in 1 year, in 20 months, in 24 months, in 3 years, or even longer, right? And there are checkpoints within your journey, right? So there are 3 project courses. There's the milestone 1 project course, milestone 2 project course that Kevyn mentioned, and finally there's the capstone project that Elle and I have been teaching. So that is the opportunity for you to synergize what you have learned before taking the course, and then to, since people may have spent 1 year up to the milestone 1, some people may just spend 3 months and now they're at milestone 1. So this is an opportunity for you to actually work with a cohort of students, do some team projects, refresh your memory about what you have learned, and then get prepared for the next phase of the project, of the program. So this is how the flexibility works.
Great, thank you. And it is really flexible, right? We've seen people that have successfully navigated the program in a year. Can be done. And we've had other folks who've indicated that they would like to do the degree in 3 years. Occasionally, we've had folks, for example, that have been affected by things happening in life and in the world. And so they've taken their number of courses per month down, or they've taken a term off and then come back, for example, and that may extend their degree timeline into, for instance, 4 years. And that's possible too. So the objective really is to be sensitive to all of those things that are happening in the world and for people in their communities, and be responsive to how plans can change, but still really support people in persisting and getting that master's degree. So you did surface working on teams. And of course, in our program, you're mostly, if not exclusively, doing that in our project-based courses, our 2 milestones and our capstone course. Elle, as Qiaozhu indicated, teach that course with him. Can you talk a little bit about how teamwork works there and some of the benefits of using a team-based approach in a course like that?
Yeah, so most data science projects that get carried out in the real world are collaborations, right? You're always going to have to rely on, somebody to get the data set for you and somebody to help you, possibly clean it, or you might need somebody who's an expert in the subject matter to guide the analyses and figure out what questions are truly of value here. And then possibly you would have somebody who helps you present it and turn it into a really compelling story. And so, data science is not done in isolation most of the time. That was actually kind of weird for me to learn because I come from an academic background in neuroscience research, and I was used to spending very long periods of time doing things entirely by myself. But it's kind of cool when you find out you can actually accomplish more when you have a couple of teammates. So we do it partially because of it's actually the skill that you have to learn, and learning how to collaborate with people, with large data sets and with code is its own type of craftsmanship and skill set that you really do want to master as a data scientist, right? Because if you will always have team members in your organization, and you've got to be able to communicate what analyses you're doing, what you want to do, where your data's from, and what your results are in a way that's reproducible and clear and easy for other people to make sense of. So part of it is pedagogical, but also some of it is just that I think people come up with really cool and ambitious things when they have a team to do it with. So we have had some, I just think you can cover more, you can experiment more, you can make a bigger splash when you put a couple people together.
Also, we have teams that are all in the same time zone, and we have teams that are literally around the world in different time zones. I've been a coach for Milestone 2 projects where somebody was been in France, Australia, and Hong Kong, for example. So it's a diverse group, and also, by the way, if we don't allocate teams we allow you to form your own team, which may just be you. If you want to work on your own, that's perfectly fine as well.
Kevyn, your timing was actually brilliant, because I was just going to turn over to you and ask you to actually talk a little bit about the diversity within the MADS program. So, for example, we've gotten questions about age and professional background. You just touched on something that I think is really important to us, and that is geographic diversity. So we have MADS students on every continent in the world except for Antarctica. It is going to happen one day, I think. So we've got a lot of diversity. Can you tell us just a little bit more about what you've observed in your role as a faculty in our program?
Well, as I sort of said earlier, first of all, like looking at the incredible backgrounds that students have from all walks of life. As Qiaozhu well summarized, people have lots of different goals when they're in the program, in terms of their own careers, but it's been great to see them sort of come together in teams toward a shared goal on these projects. I mean, we do try, just about the time zone issue, today I met with one of my milestone 2 teams. I met with them for about 45 minutes. They actually had some exciting results, which I think they could probably publish a paper on if they wanted to. But they were in Taiwan, Hong Kong, and Shanghai. And so we realize that MADS is a global program, and we try to adjust. We try to make sure in terms of office hours and when we meet with teams that there are slots available that are suitable for people globally. But I think, yeah, I think the diversity of backgrounds, it's great to see a team of 3 people working together. Sometimes there are 2 or 3 professionals that are in the same, in finance, for example, obviously maybe they didn't know each other before, but they're learning from each other about the business. Other times it's diversity in approach. We've had teams where one person's really interested in the visualization aspect, one person's really fascinated by the statistics involved, and one person really likes programming in the systems and running big jobs in the cloud and things like that. So to me as an instructor, that's one of the really wonderful things. I learn a lot from my math students. It's just, it really is incredible, the backgrounds that people have and what they bring to the degree and to the project. So just as an example of some of the diversity, in milestone 2, for example, there was one project where somebody was really interested in a research career and was working with a research group at the university on earthquake analysis with huge amounts of data. Their goal was to become proficient in seismology and so forth. Other folks came from an automotive industry, and they were using NLP to analyze all the the engineering requirements for documents in the company. People are in the hotel industry trying to focus, looking at the forecasting demand and things like that. It's great for me because I get to see all these cool problems that people are fascinated by. So I'm sort of in the middle of it all. I get to sort of switch between all these really cool things. So I see a huge amount of diversity in many different dimensions.
Thank you so much. It is really one of the things that I'm most proud of, being a person that contributes to this fantastic program. And that is really the diversity that we've been able to achieve in a short period of time across so many different dimensions that I think make our community really robust. So speaking of being sensitive to time zones differences, for example, Qiaozhu, someone is asking if our classes are generally synchronous or asynchronous. Can you talk just a little bit about how we use an approach that is, again, responsive to where our students are located around the world?
Mm-hmm. Sure. So as we said that when we're designing the courses, we balance between rigor and flexibility. If you take the maths course, you will find both the asynchronous part and the synchronous part. The asynchronous part are the course content, the videos that were made by our faculty members in professional studios, and the reading materials, the homework assignments. You can basically pick whatever time you feel the most comfortable in a day, right, in a week, to work on them. There's also the synchronized piece, which are the live office hours, right? So the instructors of our courses will host office hours, carefully planned for people in different time zones. And then when you log into the office hours, it's like a Zoom session like this, right? You can actually interact face-to-face with the instructors, ask some questions, and discuss the problems with other students in office hour, right? All the office hours will be recorded and made available to people who couldn't access and who couldn't attend them in the same time zone. And also, we have the Slack channel. That is the blended version of both synchronized and asynchronized discussion, right? So on the Slack channel, we create a channel for every course where you can actually hang out with all the students who are taking this course this month and all the instructors. If you have questions, you post a question in the Slack channel. Sometimes they get answered in seconds, right, when people are actually monitoring the Slack channel, right? And most of them got answered within 24 hours. Right, so you can choose your own, comfort time management, whatever, to find what's best for you, right? If you like to interact face-to-face with instructors, definitely attend office hours, right? If you like to, take a step back and think carefully before you ask questions, then, use the Slack channel.
Excellent, thank you. Yeah, we have a really robust. I feel like I keep using that word, but it actually meets so many of the objectives that we're trying to see through in the maths degree, and that includes our Slack community, and it's just a highly engaged community. So that's probably a better way of putting it. In fact, in addition to the asynchronous and synchronous elements that we bring to the program. And in our office hours, of course, Qiaozhu, as you and I have talked often about, we really are looking at like, okay, where are our students this term, right? Where around the world are they? How can we ensure that we structure our engagement so we're meeting the most number of people that we can at any one time in a live environment, in addition to giving people that flexibility to work in a self-paced way as well.
I just want to mention too that like in my course, I also have early morning one-on-one time slots available for students, for people who are in Asia, for example. And I also have I can meet at other times one-on-one. So beyond the office hours. And what I tell students is it's sort of an open door time where if you want to discuss careers in data science, I'm happy to do that. So yeah, just wanted to mention that.
Thank you, Kevin. I'm glad you did. So we do have a handful of admissions questions, and some of them are fairly specific. So in an instance where you're asking a question that pertains to you, I do encourage you to email umsi.mads@umich.edu in order to get an answer to those specific questions. However, there are a couple of general questions that I would be happy to just touch on now as we start to wrap up and before I turn it over to our panelists one more time. So for spring summer admissions, so that's for classes that start in May 2022, our priority deadline is February 1st. And if you submit your application by priority deadline, the incentive to doing so is you get to information about your admission decision before anyone else. So anyone that meets that priority decision gets an early admission decision, essentially. And you also get first consideration for scholarships. And we do offer modest scholarships in the maths degree, which is somewhat unique for an online program. And so for those reasons, if you feel like you're fairly well prepared and ready to submit the application, I strongly encourage you to do that. Every term, we have a varying number of applicants that are coming into our program, and we use a holistic review process when assessing applicants. So yes, that includes things like undergraduate degree transcripts and academic performance, but for some of you, you've been out of undergraduate degree for 10, 15, 20 years. And so it also would include things like work experience and a letter of recommendation from a colleague or an employer. And it may include, for example, the kinds of work that you've done in projects or your certificate of completion of Python 3. So we're not necessarily looking at one specific thing when making decisions. Our admissions team is actually really good at using a holistic approach when evaluating applications. The program is pretty selective, but at the same time, we're also really supportive of folks that want to get into it. We run 3 admission cycles every year. So again, we're offering lots of flexibility around when you start. And so we want to encourage everyone that's on our webinar today and all of those of you that will join us afterwards when you watch the recording to absolutely apply to the degree program. And again, if you have questions about your specific application, to reach out to our great admissions team at umsi.mads@umich.edu before submitting your application in order to get those good questions answered. So as we start to wrap up, I was hoping that each of you could just take a moment to tell us why the maths degree. So if I was an applicant, if I was somebody that was interested in pursuing the degree and maybe a degree in a number of different programs, why should I choose maths? So Elle, can you go ahead and start us out?
Yeah, we have a wonderful community, really, really, really cool people. The Slack channel that we have, one of the things when I started teaching for an online program, I was wondering how much it would feel like there was a community, and it's kind of amazing. You really do get to know people, and the network is is so cool. The flexibility, like I said, I have my students kind of amaze me with how broad their backgrounds are. And so, I think that speaks to how many people can find their footing here and make it work with their lifestyle, whether wherever you are in the world, whatever your home life is, whatever kind of job you're currently working, there's just a ton of flexibility. And yet at the same time, there still somehow is this really wonderful core community. I just think it seems like a lot of people really fit quite nicely with us.
I concur. Kevin, what would you say?
I would just simply say, sort of echoing what Elle and Qiaozhu have said earlier, that we've worked really hard to create a program that is inclusive, that understands that people come from a variety of backgrounds, a variety of countries, a variety of interests and motivations. We've worked really hard to create a program that is rigorous and flexible, and especially in how it ramps you up from sort of beginning Python knowledge once you're into the program. After that, then through sort of the being able to manipulate data, as Qiaozhu said, and then increasing data and getting more and more sophisticated. So we've had to really coordinate among the courses to do that, and I think we've done a good job. And so I think it's a really well-designed pathway that works well for a broad, that understands that people come from a broad set of backgrounds. So it's technically rigorous, but it's designed in a way and paced in a way, I think, that gets you to where you want to be in a way that's thoughtful, and while still covering a lot of great technical material.
Excellent. Thank you, Kevin. And Qiaozhu.
Well, our goal is to build the best data science program in the world. It's not building the best online data science program in the world. It's to build the best data science program in the world. And that cannot be done without your help. We can see that, we're really proud of our students. Our students are helping us to shape the future of the program, right? We're taking lots of valuable feedbacks from our students, and that helps us to iterate, to evolve, sometimes to revolve some of the, our vision and design. So together, I think we can actually make this happen. We can not only build the best data science program, and we will end up with having the best data scientist community who are really using these techniques to change the world.
Thank you. Well, all of those answers were incredibly well said. And so I would like to say thank you again for joining us this afternoon or morning or evening, depending on where you're located around the world. We really appreciated spending about an hour together, learning and talking more about the maths degree program. We're very eager to see all of your applications. And as always, go blue.